Hello, so my name is Aaron Winkle. I'm an electrical and computer engineering major who's pursuing minors in both math and computer science. And today I'm going to be giving a short, about 7-8 minute long presentation on recursion and Python, a topic that's covered pretty in depth, I'd say, in CS 120. And I might relate it a little. I'm going to focus on relating it to linked lists specifically, but I might briefly mention like graphs or just general recursion as well. So this is obviously going to be in Python since I'm talking about computer CS 120. And so let's get started. So obviously in computer science, loops are very important. Like you can create functions to create with while loops that can do things such as compute factorials. So if we create this function to compute a factorial, we could do this with a while loop where we'd simply start with something like we declare a product variable that we would or that we would slowly multiply everything to. So we could go, well, n is not equal to 1, obviously. Product times equals. So we're going to be multiplying by n each time, and then we're going to reduce the value of n by 1 each time. And then we'll return the product in the end. So what this will do is we'll start with a product of 1. We can't start with 0 because that would just defeat the whole purpose of this. And we'll start with n, and we'll multiply product, which will start at 1, by n. So if we input, let's say we input 5 as n, this will start with 5, so it'll do 1 times 5, which is obviously 5. And then it'll reduce that to 4, so then it'll go over here and do 5 times 4, which is 20. Reduce it to 3, and it'll keep iterating like that. So if we run this, right here we could see that we got a value of 120, which is the correct one. I computed that before. So yeah, so that's the way to do this with a while loop. However, there is obviously for loops, but there's also another type of loop, and it's recursive loops. A recursive loop is essentially a function that will call itself repeatedly to complete a task between each call to function, and the input parameter will be reduced each time. So we're reducing it n by 1 each time here, so we could potentially do that recursively. We could define this function to take n as a parameter again. And so one issue with our other code up there actually is that we don't check if n is less than 1 or something. So like if you input 0, this will actually result in an infinite loop, which since this is an example, it's not necessarily a big issue, but if you're going to be writing like an actual program that you don't want to have a ton of issues with, I would highly recommend checking for that case. Maybe changing this to if n is greater than 1 or n is greater than or equal to 1, so then it will at least exit at a certain point. But yeah, so regardless, what we're going to do now is we're going to write a recursive version of that function. So we could assert that n is greater than 0, but again, I won't do that. So we do need a recursive case and a base case. Now, a base case will cause us to exit the loop. So essentially, the base case will be some sort of case. So like when n is 1, we'll just return 1. So we won't call the function again. And the recursive case will continue the recursion steps. So they're actually going to write the recursive case first right here. And this will make the code very simple, probably around 3 lines actually. So if n is not equal to 1, so if it's 5, let's say we input 5 as a parameter, we'll return n times compute this recursively, and we'll input n minus 1 as a parameter. Now why n minus 1, and why do we do it like this, where we return this? Well, so let's say we input, actually we do need to write the base case first. So we don't need to check for anything, because if it's not equal to 1, then since we're assuming that they're inputting a number greater than 1, greater than or equal to 1 that is, we can just return n, because it will automatically exit the function right there if it's a recursive case. So yeah, if let's do the example of 5 like we did down here. So we remember that was 120, right? Yeah. Got 120 when we called that. So let's input 5. We'll just think about it by hand before we call it to make sure there's not going to be an error. So input 5. We'll do 5 times whatever this function is, but called with 4 since it's 5 minus 1. So we'll go down here and we'll do 4 times this function called again, but with 3. And we keep going until we get to n equals 1. And now it's since n is not equal to 1, we're not going to continue the recursion. We're going to go down here and just return 1. So then we'll go back into the last loop that called this, and this will now become essentially 1. So it'll basically be 1 multiplied by 2, since in that case that's what it'll be. So then this will return a value of 2. So, and then it'll continue up until you get to 5 times 4 factorial, essentially. And then we'll just return the result after that. Or yeah, it'll return the result right here. So if we change this right here to do this recursively, we'll actually get 120 again. And in this case, I personally believe that this is a much more efficient code. Like, it runs 3 times rather, or it only has 3 lines of code rather than 5. I mean, that's not a big difference, but in major programs, having your code be like half the size of another program, that's a big difference, I would say. So yeah, that's one thing we can do. So that's a very simple example. So we could do a more complicated example too. So I'm going to do an example involving linked lists now. So to keep this video pretty short, like in the 7 to 8 minute range, I'm actually just going to copy and paste some code that I wrote previously. So I'm going to just paste in the node class for a linked list. This is a simple class. It just initializes a node right here. It says a constructor. Then we have a get val. We have getters and setters for val and next. And yeah, so then I'm also going to paste in a little bit more code. I'm going to paste in examples for, I'm going to paste in a main. And I'm also going to paste in a few more functions that are written both recursively and with loops. So right here we have the main. This is just going to run it basically. It'll run a few tests. But we can walk through these real quick. So you could print a list regularly. We just, a linked list where you just say cur is equal to head. While it's not none, you can just print the value and then iterate to the next one. That's a very simple way to do this. You could also do it recursively. It takes about the same amount of code, not much difference. Again, it's a very simple function. So if the head is not equal to none, we're going to print the value and then we're going to recursively call the next one. And we actually don't need a base case in this, for this one, because when the head is none, we just don't want to do anything, unless you want to print out none, that is. And then another function I wrote here is just find val. So if we have a linked list, this is going to create a linked list, my example code here, with numbers 0 to 9, with nodes that have values from 0 to 9, that is. And let's say we want to find a value in here. So in my code, we're going to look for 5 in the list. So that's what we start with. It'll start with the head, and then it will iterate through the list till it finds the value. If it finds it, it'll return cur. And then if it runs through this while loop without finding the value, it will just return none because it's not in the list. And we can also do this recursively. So if head is not, so we'll start with the head, obviously, and if the head, so this is actually a base case right here, because if the head is none, we actually don't want to continue, because if we continue, we try to get the value of a none, of an object of type that's just none, we'll throw an error. So this is the first base case we want to check for. If it's none, just return none, because the only reason we're going to reach this case right here is this is not only accounting for the situation in which the head is initially none, but it'll also be the case where we've iterated through the entire list, reached the end, and haven't found the value, so it doesn't exist. But yeah, and then another base case is obviously we reach the value. We want to stop going through the list. We don't want to keep going because that's just going to waste time and it's going to increase our time complexity, make the code run longer than it needs to. And yeah, so if neither of these are reached, so if we don't find the value, we're not at the end of the list, we want to go to the next value. So we're going to actually pass through head.getNext. So we're going to go from the head to the next value in the list, and we're going to continue this. So yeah, my main will test all of these functions for us. So it'll test the recursives for us. So it'll test the non-recursive version and the recursive version. So we compare the outputs side by side. So I'm actually going to expand the console a little bit just so we can see that, because these are going to print really long lists. So non-recursively, obviously, we called it right here, just print list regularly, and printed out perfectly fine, got every value. Cursively, beautiful, same thing. And we're going to check for 5 in the list first. So we found 5. I just had it return the node that contained the value. And then we're going to check for 10, which doesn't exist. So this test case is actually really good because it not only tests when we have a value, but we also don't have the value in the list. So that tests two different cases. There's obviously more you can test, but for this is good enough. Um, so we're going to check for 4 recursively now. So it's different value. And we do in fact find 4. So, and now I'm going to test and make sure it actually exits properly and doesn't continue into infinite recursion or trying to check for a value of a node that is actually none. So we actually return none because we don't find it. So I had it return none if it's not in the list. So yeah, that's pretty much it. I would say there's obviously more you can do, like you can recursively. There's just it's crazy with what you can do. Yeah. But yeah, so I would say the main things that we learned were what a base case is. It's a function. It's a case that will cause the function to exit the recursive loop when it's met, such as finding the value in the list. And we have the recursive case, which is a case that will cause it to go deeper into recursion or call the function again, but with a reduced input. So, for example, if the value is not found in ours right here, we will actually go to the next node, reducing the size of the list by 1 and checking that node and continuing from there. But yeah, so recursion is very useful, and linked lists has a lot of other applications that I briefly mentioned, and we'll get into that later in CS120. But yeah, all right, take care.